Hello students, next topic is different types of fuel cells. So based on the electrolyte used inside this fuel cell, the different types of fuel cells are alkaline, proton exchange membrane, direct methanol, phosphoric acid, molten carbonate and solid oxide. First one, alkaline fuel cell or AFC. So as the name indicates, here the electrolyte is alkaline, that is an aqueous solution of potassium hydroxide. So potassium hydroxide is KOH. So aqueous solution of potassium hydroxide is used as the electrolyte here. So compared to the acid electrolyte, alkaline electrolyte has a high performance and it is also less corrosive towards the electrodes, and the electrical efficiency is up to 60%. And the disadvantage of this fuel cell is that it requires pure hydrogen as fuel and it operates at low temperatures, about 80 degrees Celsius. So since it operates at low temperatures, we can use this fuel cell for vehicle applications. So that is alkaline fuel cell. Next one, proton exchange membrane. So here in proton exchange membrane, it uses solid electrolyte and it operates at around 80 degrees Celsius, and the solid polymer electrolyte used here is a chemical compound called naphthalene. Okay, so these fuel cells are also known as solid polymer membrane fuel cells, and the electrical efficiency is 40%, and since the temperature is low, it is suitable for vehicle applications. And compared with the alkaline fuel cell, here impure hydrogen can also be used inside this fuel cell, whereas in case of alkaline fuel cell, only pure hydrogen can be used inside this fuel cell. So that is an added advantage of this proton exchange membrane. Third one is direct methanol fuel cell. So the disadvantage of fuel cell is that the hydrogen fuel used inside fuel cell, it is expensive as well as the storage is very much difficult. So in this case, in direct methanol fuel cell, here methanol is used as the fuel and from methanol hydrogen is extracted. So methanol fuel is carried on board a vehicle and it is reformed to supply hydrogen to the fuel cell, and it works on the same principle as the previous one, proton exchange membrane, and but the temperature is high, that is about 90 to 120 degrees Celsius, and the electrical efficiency is 30%. Next one is phosphoric acid fuel cell, PAFC. So here the electrolyte used is phosphoric acid and it operates at a temperature of about 200 degrees Celsius, so which makes some cogeneration possible. That is, using the heat used inside this fuel cell, it can also be used for other domestic purposes like space heating and all. So that is cogeneration, and the electrical efficiency is about 40%, and these fuel cells are considered too bulky for transportation applications. Next one is molten carbonate fuel cell, MCFC. So here as cathode carbon monoxide or carbon dioxide is used, and as anode hydrogen is used. It operates at a high temperature, that is about 600 degrees Celsius. So here also cogeneration is possible, and the cell uses carbonate as the electrolyte. The electrical efficiency is 50%. So here the excess heat can be used for cogeneration purposes, and here it operates at high temperature. So it is not suitable for vehicle applications, but it can be used for stationary power generation. Sixth one is solid oxide fuel cell, SOFC, and also ITSOFC, that is intermediate temperature solid oxide fuel cell. Solid oxide fuel cell uses a solid ionic conductor, that is yttria stabilized zirconia, as the electrolyte rather than a solution or a polymer. So here as electrolyte, solid polymer is used. Solid ionic conductor is used, so we can reduce corrosion of electrolyte. And the disadvantage is that it operates at very high temperature, that is about 1000 degrees Celsius. So this make it unsuitable for vehicular applications, but there is intermediate temperature solid oxide fuel cell which operates at lower temperatures. So this is not a good choice for vehicular applications, but it can be used for stationary power generation. So this table shows the comparison between different fuel cell. First one, alkaline fuel cell. The mobile ion is OH minus because the electrolyte used is alkaline, and the ion is OH minus. Operating temperature is about 50 to 200 degrees Celsius, used in space vehicles, and that is the application. Proton exchange membrane fuel cell. Ion is H plus. Operating temperature is about 30 to 100 degrees Celsius. It can used in vehicle as well as mobile applications and for lower power CHP system, because the temperature is very less here, so it can used for vehicle applications and also for low power CHP system, that is cogeneration system. Next one, direct methanol fuel cell. It operates at a temperature of 20 to 90 degrees Celsius. So suitable for portable electronic systems of low power running for long times. And phosphoric acid operates at a high temperature 220 degrees Celsius. So here cogeneration is possible, because since it is operating at a high temperature, cogeneration is possible, that is about 200 kW CHP systems. Molten carbonate, here also the temperature is very high, so it is suitable for medium to large scale CHP system. CHP means combined heat and power, and up to megawatt capacity. Last one is solid oxide, SOFC. So it operates at a very high temperature at about 1000 degrees Celsius. So here also cogeneration is possible, so it is suitable for all sizes of CHP system 2 kilowatt to multi megawatt. So this is all about the types of fuel cells. Thank you.